welcome to another masterclass produced by Ziggurat Institute of Technology. My name is Laura Ferreira. I'm product manager here at Ziggurat. And for those who may not know us, Ziggurat is an international institute of technology with over 20 years of experience in the field of online education. We provide online masterclasses. We provide online masters and postgrad programs in construction, engineering, and innovation. Today's session is framed in the program Global Masters in HVAC Systems and Energy Efficiency Design program. To learn more, please scan our QR code. Should be here. Here. Perfect. And today we have with us Arnau Sanchez of CENER, and who will share with us his experience in the HVAC project at the Devon Airport in Colorado, USA. Plus, with us also is Benjamin Gonzalez.
Hello, Laura.
From CIPE, and he will also share his vision on HVAC design and BIM environment. Well, thank you very much. I will leave the word for Arnau, if you can start.
Okay, I will share my screen.
And now the right screen, remember. The right screen, just in case. Yes.
Can you see the?
Yes, the right one, yes.
Okay. Well, just introduce me briefly. Well, thank you everyone for your attendance. And it's a pleasure for me to share my experience in this project, which is the Denver Airport. Concretely, I will explain the air conditioning system of this unit building. First of all, just introduce that I am industrial engineering with 17 years of experience. All my experience has been dedicated in facilities project development. And especially in the last 7 years, I have been focused in the subdiscipline that I enjoy more, which is the heating, ventilation, and air conditioning. So in CENER, CENER is the company which I work with, and I will explain you first of all the topics that we are going to talk in this season. First of all, I will talk briefly about CENER, about the company that I work on, and then I will talk about the project. The main of the season will be focused on the HVAC design, the basis of design, the heat and cold production, the distribution, air treatment, the AV system, and some things that miscellaneous things that I will focus on the end. Well, CENER it's an engineering that has three main units, which the first one is aerospatial, then have renewable investments, and then there is the main unit, which is engineering with three focus, which are marine and energy plants and transport infrastructures, which are railway, urban transport, roads, airports, like this case, ports, singular architecture, and water and environment. Well, the project, this is the project. This is the building, and this is the singular roof. That it's this kind of roof. It wants to represent the Rocky Mountains that you can see behind, the Rocky Mountain in Colorado, and this kind of roof will be a key on the HVAC development of the project, as you will see in detail later. Well, first of all, I would like to highlight that this this is a presentation that it's shorter than what we used to do in the master degree, and because here we have a limited time of 30 minutes, and in the master degree it takes 1 hour and a half. So I will try to summarize this presentation. So we will see all the topics in any case, but we will see in a superficial way. So just apologize if there is something that it's not completely clear. We will have a case. You will have the chance to make your questions at the end. Well, then Denver Airport. Well, even though Denver is not one of the highest cities in US, it is the biggest airport in surface, and it's the 5th biggest airport regarding traffic in the country. It is because it's a strategic airport located on the center of the country. You can see here this picture. This is the airport, and there are the main the main concourse at this location, and then there are 3 additional concourse located here. And this is the scope of our work. It's located on this part of the building. Well, this is what it's called the main hall, and the project is 115,000 square meters, and it is an investment of 518 million euros. You can see here inside the appearance of the roof that we said at the beginning of the presentation, that it will be something critical to be resolved from the HVAC point of view. Well, that's the organization chart. It's typical of that kind of projects where the constructor is located on the middle. It's not only constructor, because they have also contract the operation of the airport, and we Sener and our partner, it's an US engineering, that we were focused on the installations and communications. Then there is another team who was in charge of architecture, life and safety, structures, and baggage claim. And then we have the stakeholders, typical, well, the promoter, who is the Denver Airport, the firefighters, and the council. Well, regarding the HVAC design, first of all, I would like to emphasize that the background of any project, are the main regulations and standards. In that case, in USA, it was the ASHRAE, the ARI, and the SMACNA, and others. And in this case, particularly, the airport has a design manual called Design Standards Manual Mechanical, in that case, and it's an open document that you can go through it, and it's very well detailed, all how should be designed all the facilities that has been enlarged or refurbished in this airport. It was as our Bible here in this project. Well, regarding calculations, the heat gain calculations in that case were calculated by the software Trace, and it's an international software, and maybe it's not so relevant as other softwares, but it has a very significant advantage that you can see all the calculations summarized in a single page for each room. So it makes easier to manage all that information, and also it's easier to verify all the data that has been calculated here. Well, the production in this project was not affected because we did not need an enlargement of the cooling capacity and heating capacity. So the cooling capacity was enough for the enlargement of the airport. So, but any case, I think it's a very interesting part that I should explain here, because what was installed in the Denver airport, it's a kind of district cooling and district heating, because they have a single point of production of cold water and hot water. As you can see here, the technology that is used, it's a typical chiller water condensed by water, and with using a cooling tower to dissipate the heat generated. And this is maybe the most efficient system that can be installed for this large facility. And even though it's not very common here in Spain and other in Europe, maybe, because the Legionella risk, but in US it's not a problem. They are very, and they are very confident of the maintenance of those equipments, and it's very common use this kind of equipment. Regarding the heat production, what we have here, there are natural gas boilers. We have, as you can see, a significant heating capacity. In that case, the outdoor cooling temperature design, it was quite low. It was minus 16 degrees. And for that reason, it was necessary a high heating capacity. Well, then regarding the distribution, there was primary supply pumps. There was only 4 pumps, but as you can see here, the power of these pumps, 200 horsepower. So it's a very huge pumps. You can see the main head. It's 36 inch, what means it's like a meter of the main pipe. So it's a very, very large facility, and it's distributed to 6 secondary pressure groups. And our scope of works is located in one of those secondary pressure groups. Is where is located the Great Hall. In this Great Hall, we have a the 4th level is where we have located all the mechanical rooms, where we have the air handling units. The air handling units was all of those equipments were existing, and we made a refurbishment of those equipments. We had 8 mechanical rooms and an overall of 24 units. And well, what we have done in those units, we have changed the cooling batteries, the heating batteries, the filters bank. We have substituted the fans, and everything has been removed inside those units and has been substituted by new ones. Then from this air handling unit room, we supply the air to the upper levels. So the Great Hall is located here in the level 5 and level 6. Below levels are for parking area. So from this mechanical area, we supply ducts to the level 5 and 6. And this air is returned to the same room through a plenum, a return plenum. And part of this air is returned to the equipment, and another part is extracted by the deck exhaust fans. And we have an additional plenum for the primary air in order to have outdoor air here in the building. Additionally, we have also the kitchen exhaust ducts, and we have also at the upper part of this singular roof, we have the smoke exhaust fans. Well, we have two kind of systems of the air conditioning systems here from the air side talking. We have the great hall that we are supplying through jet nozzles with a constant airflow, but a variable temperature supply. And for the rest of the areas, we have a constant temperature supply and variable flow rate. For those areas, we use this VAV system, so these VAV boxes. Well, it's a very typical system in United States. Maybe in Europe, we don't use that system much a lot, but it's very common there, and it provides a significant advantage that it provides you the chance to take profit of the pre-cooling a lot of hours of the year. And we have a temperature sensor in each room, and we have also an airflow sensor in the equipment. And with these two inputs, the control box will modulate the damper, which will define the flow rate that this room requires in order to have a suitable temperature. Well, one of the most critical part of the facilities is this roof that we mentioned at the beginning. And this room, as you can imagine, well, it's not a single layer. It's a double layer with a air camera inside. But in any case, the transmittance of this roof is very high. So this roof will make that the surface temperature inside the building will be very, very low, because since we have minus 16 degrees outside, we could have here very low temperatures on the surface, and then it will generate condensate on the surface, and we could have rain inside the building, and it's something that it's very important to avoid. And that's why we have some air handling units, especially for the air conditioning of this camera. So we are supplying air through this space between the two layers in order to have a surface temperature much high. We will have a temperature around 60 degrees, and it will make that we will assure that we will not have condensate here on the surface. This is not a very efficient system, but it's something that it was a must, because otherwise it is a must, because this unique roof that requires that system. In other cases, the efficiency of the system has been prioritized. It is regarding the infiltration control. Here there is a significant wind in this area. So in order to prevent infiltrations, there are several systems used that will prevent these infiltrations very accurately. And we will have a double door access. We have these doors and another arrow doors below. And we will have a curtain here above these initial doors. And additionally, we will have a building of air pressurization. So we will have pressure sensors inside the building and pressure sensors outside the building in order to control all the time what's the difference between the supply air and the exhaust air in order to have this building with a minimum pressurization in order to avoid those infiltrations. There is in all airports, there is a significant number of tenants, and it's an important part of the airport because but the facilities inside of the tenants were not inside our scope of works. However, our facilities, we need to provide the tools in order they are able to develop the facilities inside. So we provide primary air ducts, we provide an exhaust duct for the kitchen, we provide compensation duct for the makeup air in the kitchen. We provide as well hot water and cold water for the air conditioning and heating, and obviously there is energy meters in order that the airport could measure the energy of each tenant is consuming, and then they will pay for it. We have in this project we have also the air conditioning of communications room. So we had an IT room that we need to use in that case what we call crack units. Well, but it's an abbreviation of computer room air conditioning unit. So these kind of units are very common for those rooms, and we can handle the air in order to have a very accurate temperature, not only a temperature, but also humidity. And we have an humidifier and electrical resistance to eliminate humidity of the air, and also AC ventilation fan variable speed. Here in this building, obviously we need a very smart control. For that reason, we have here a building management system, not only for HVAC, but also for lighting and the rest of the facilities. But well, in this part, we had a network to control every single unit and control every single sensor in order to make the maintenance tasks and regulations and so on. Well, this project was developed with building information modeling software. In that case, it was used Revit. It was developed in a collaborative way. So it means that we use the Autodesk platform. We didn't use our servers. So we, not only us, the rest of the teams, where we were together collaborating in a single platform on the cloud. The architecture, the structures, all the facilities, the baggage claim, and everything. It was modeling, and in that case it was modeling just in time. So it means that every time that I save the work that I am doing in my model, it was synchronized with the rest of the team. So it seems very, very useful, because there is it's a project that it's very difficult to coordinate. But in that case, it was it was probably a mistake, because working in that way with such a big project, it makes that the computer needs to operate a lot of time for every task, and that makes us to work efficiently. So it could be better to update the models once a week, and it will let us work fastly. Well, for that kind of projects in BIM, we had here also, we developed a BIM execution plan, but this BIM execution plan was based in design standard manual BIM from the airport, that it was similar like the standard for mechanical facilities, but for focus on the BIM, where it was defined how to work with this tool, or the information that all the equipment should contain, the name of the parameters, everything was very well detailed, because the airport is using this tool for the maintenance task. So they want everything modeled in the way they can integrate with the rest of the airport models that they have. Well, working in that way, it have significant advantages, because we were different companies working in very different models. So there was a single model just for HVAC. There was other models for plumbing, for electricity, for architecture. Was split in 3 models. Where there is a lot of information, and everything was linked for all the participants of the project. And there was some of the teams were working here in Spain, in our office in Barcelona. There were other teams that were working from USA. And we have a team of modelers that we contract in India. So, and there were many people involved, and we need a platform in the cloud like this to be able to face this project. Well, this tool, it permits to do a BIM, roof coordinations and ceiling coordinations. As you can see, it was a tough task to do in order to coordinate the work between architecture and as you can see here, the lighting and air conditioning fixtures. Thanks to this tool, we could work by phases. So it was not all the refurbishment done by once. It was done in several parts. Also, we can have a clash detection between HVAC system itself, but also between other electromechanical facilities, and also with architecture structures and so on. Also, we were able to make some calculations, especially in duct sizing and pipe sizing and pressure drop calculations, and it was very useful, because meanwhile you are modeling, you are calculating the facilities. And in that case, we use a management tool that it was called Bluebeam. Maybe it is a little bit old-fashioned, because we could do this task right now with the BIM 360 from Autodesk. But in that case, we use this tool where everyone uploads all the PDF issues to the client, and we receive here all the comments from several reviewers from the constructor, from the airport, from the council, and then we have to manage an array of comments, and very huge in some cases, that needs to be very methodology. You need a methodology. You need a methodology very accurate in order to solve all those comments that we receive from our clients. And there was something challenging in this project, that for us, there was a significant cultural differences that it was affected, but we detected a very high level of demand. it was asked very high detail in this project, the use of VAV technology that we are not used to. Well, and we also need to manage big egos, because there was a very experienced and very professional persons who manage with. And finally, regarding the units, it is always difficult to. It seems that there is a simple conversion to inches to feet to square feet, but sometimes it makes difficult to see at glance if this flow rate is enough for that room or not. If some mistakes that you can detect with a glance, here you need to operate, and well, it's an additional issue. Well, that's all from my part. At the end, we will have the chance to clarify any answer that you have, and I will let my word to Benjamin that will explain the software TIPE.
Well, and now very interesting. Laura, do you want to add something? I don't know if Laura.
No, you can go.
Yeah. Okay.
Benjamin,
thank you.
yeah.
Thank you. So thank you. And now it's. Let me share the screen. I hope to share the right one. And now, if you can wait a second, it's the right one. Perfect. Thank you. Thank you. So, hello everybody. First of all, thank you. And now that thank you, Zigurat, for inviting me to participate in this webinar. And well, it's a very interesting webinar with a huge and very singular project, the Denver Airport, and a unique HVAC project, as you say, in the presentation. And well, now is my part is to explain different tools and how we can be useful for this kind of project and normal project, regular project as well. In this case, Sype is a software company and is part of the project, the master of HVAC that Laura has explained before. And we are a software company with 40 years of experience in the market, more than 150 tools, and 200 professionals in Spain. It's a software, it's a Spanish company, and actually we have more than 100,000 customers around the world. This is a big numbers, and we develop tools for construction sector, but in four specialties: architecture, MEP, and I'm going to explain HVAC more in detail, structures, and management. I think this project, this airport, I'm sure that you had to work with a lot of specialists in different tasks. The architecture was Revit, you said before, or the structures, or bill of quantities as well. Pretty sure that you had to work with different roles and the different companies, like you said before. And we develop these four group of tools, and all of them with a common data environment, a cloud, is beamserver.cent. I will explain more in detail afterwards. This is a like of ecosystem, taking into account that 150 tools plus Revit plus third-party tools is we need a place to share the results, to share the outcomes of the different tools, and this is the cloud that we propose. Actually, it's a free cloud, and you are invited to use it whenever you want. We are focused, and I think it's very important for this kind of project and another project, is to have productive tools focused on design and analysis. Is very important, the thermal loads, the energy simulation, the lighting, the duct and pipe dicing. All of this calculation is important to do it with the different regulations, different codes, and with specialized tools. That is, we think that is very important. And the deliverables, like you said before, and now the deliverables, for example, the thermal loss in one site, you can see all the information, room per room, space per space, or maybe you need to generate a lot of deliverables, a lot of pages, because I don't know, your customer asks for that. So, well, this is what we do, different tools for every specialist, and always with open beam workflow. I will explain afterwards what is it. The point is, it's very important to have different tools where the specialty has to be very comfortable with their specialty. It's important to take into account that if you are an expert in energy simulation, you will have an energy simulation tool. The same with fire design or ducting or piping or whatever. This is very, very important. And technical support is important to have the technical support always, because this kind of tools, this kind of projects, always you will have a lot of doubts and you need support for that. And continuous improvements. The tools is not free. You need to have a very uploads and with high technology, augmented reality, virtual reality as well. And we are in a new world and we need this kind of tools with this new technology. And of course, a plug and play tool is you can download, you can install, and you can use it first day. This is important. Well, the workflow is just a comment. You can work with, we have an architectural tool, like I said before, site architecture, or maybe you can use a Revit, in this case, Allplan, ArchiCAD, and the point with this workflow, that you will see in the master of Sigurat as well, is you have a 3D model, and with this 3D model, you can generate an architectural model and share this architectural model with the different specialists. Like you said before, and now you don't need to do it, not every moment, not every week, just when you have a realized. But the important thing with this workflow is every specialist, the thermal load, the analysis, the energy simulation, lighting, they don't need to have the whole information, the big 3D project with the whole thing, only the geometrical model. And they will be in charge to generate the energy model, the thermal load model, acoustic, lighting, and so on model, and generate all the reports, all the deliverables that they need, and share this information again and again. And this is a way to avoid the problem that you discussed, that you talked before. This is part of the things that always updating the model, but not every moment, just when you want, and you don't need to restart again with the model, that you know very well what happens. About some pictures, and we will focus in HVAC. You can work with a site, OpenBeam site, and you can generate architectural model. It doesn't matter the tool that you are, but you have to take into account that we have this kind of tool. Structures as well. The HVAC is one thing, but always you can do it with the part of the structures. And MEP, mechanical, electrical, and plumbing. Mechanical, electrical, and plumbing. In this case, the energy and acoustic simulation, the HVAC, that I will say, the fire protection. I'm sure that this project, one of the things very important in the USA is very high, the NFPA regulation code, and electrical installations, telecommunications, and plumbing and wastewater. And all of these things, you can different tools. And in this case, for HVAC, the first thing is the geometrical model. Maybe you have your geometrical model from Revit, or maybe you have some drawings, or maybe it's too complex that you need to generate your geometrical model. You can use it, and we teach in this master of Sigurat how to do it. The analytical model, you are using an IFC, this is the BIM workflow, with the Open BIM standard. You can take this 3D model from ArchiCAD, from Allplan, from Revit, from Site Architecture as well, and you can take and use and generate the 3D model. And afterwards, to design to analyze the thermal loads. The thermal loads is in accordance with ASRAE regulation. We think that this is very important. Is the RTS methodology, and well, this is, I think, is the most recognized methodology around the world, and we use it in this case with this tool. The modeling and energy simulation, we have thermal loads, and the energy simulation, we use Energy Plus. This is another American engine, very useful, and you can, with the same 3D model, you can generate this energy simulation. And one of the important things why you are simulating things is because you need to improve the solution. And in this case, we use the improvement measures with this kind of tools, comparing the different hypotheses, the different options of the building or the different HVAC solutions. And in the end, one thing that you have say is the lighting connecting to the energy simulation, but you can analyze, you can design the lighting. In this case, we use Radiance engine. Radiance is an American engine as well, and you can use it in this tool, all connected with the same 3D geometrical model. And in the end, focusing on the HVAC flow diagrams. The flow diagrams is very important. It's the first step to generate the drawings, to generate the sizing. Is when you need to think about how many chillers you need, how many AHUs you need, and so on. And you can do it with this kind of tool. That work, you can put the different work, and the sizing and the AHUs is very important to analyze what is the demand of every connecting to the thermal loads, and to generate the needs for the manufacturer, because every AHU is different. And the water distribution system is the same. You set the piping, and you can take where the chiller is, where the heat pump, and whatever, the fan coil, and so on, and design and analyze all the piping from this building, the airport, or another one. At the end, you have the whole project that we have talked before, and the project management. You need to manage this project. This manages bill of quantities. This manage is health and safety. This manage is the cost management, and all of these things you can do it with this kind of tools, that this solution that we propose, and you learn this master. And the common data environment, the cloud that we propose is a free cloud. Actually, it's a common data environment that you can manage the project via website, via a smartphone or tablet, and via the highest technology like augmented and virtual reality. To summarize, you can use 3D modeling, you can use the best engines around the world, the best reports, you can use it, reports that you need, in this case for Denver, for units, for example, that you say the international units, the American, the British units, or a mixture. All these tools you can customize your units in order to avoid these problems about the units. And the drawings, 3Ds and 2D, like you can see here, and all of them connected to the bill of quantities simulation. At the end, what we propose, and this master you can learn, is how to do it and to use tools to do it, the best design, the HVAC design, and the energy efficiency energy design, and in one word is productivity. And this is what we propose, and we will be very glad to see you very soon. Thank you very much. Now, Laura, I think it's your turn.
Sorry, Laura, you are
muted. Thank you very much. And thank you, both of you. I will just share my screen really quick. yes, it was very interesting presentation. Thank you very much, Arnau and Benjamin. I'm sure everybody who was here got interested. And I would like to thank also the people who are here in this masterclass, and mention again, if you are interested in learn more about our masters in Achivac, you can scan the QR code. And thank you. See you the next time. Bye bye.